Hello everyone, pragyanbo here with a quick crash course on NumPy. This is my first tutorial and I've been planning to make more. So if you guys have any recommendations or requests after watching this video, just write it out in the comment section and I'll go through them. So this is Jupyter Lab. If you guys aren't familiar with it, it just came out like a week before and it's a stable release, so it's working fine and I certainly recommend it. Now let's get into the topic. So let's start off by importing NumPy as NP. So in Python there's a data type known as list. Let me show you. I'm sure some of you guys are familiar with it. So there you go, that's the list. So what we can do is we can convert this list into a NumPy ND array. I'll be using the np.array function, which takes in the variable as a parameter and it generates a NumPy ND array. So if you guys actually want to see the type of this, so that's a NumPy ND array and it looks like this. So this is not quite commonly used except in limited cases where you actually have to change the list into a NumPy ND array. So instead of this, we are going to be using inbuilt functions to generate ND arrays. The one that I mostly use is np.arrange, which works like the range function in Python. So here you give a start value and a stop value. What you have to keep in mind is that the stop value is not actually included in the ND array. So here you go, here you get a ND array of 0 to 9 without 10 being included. So if you want to include 10, you can write 11 over here. So that's 0 to 10. Another way of generating ND arrays is by using np.zeros, and if you are familiar with convolutional neural networks, this is actually used for padding purposes. So if you are not familiar with that, no worries, you can still learn from this. So np.zero actually takes in the shape as a parameter and generates the number of zeros according to that shape. So if I put in 5 over here, there are 5 zeros, and if I put in a tuple over here, so suppose 3 comma 5, here you go, 3 rows and 5 columns of zeros. Another one similar to this is np.ones that does basically the same thing but with ones. So I can also provide a tuple 2 comma 4, there you go, 2 rows 4 columns of ones. So another commonly used inbuilt function to generate ND arrays is linspace. So here it returns evenly spaced numbers over a specified interval. So I'll explain this. So let me put the start value at 10 and the stop value at 10. At the start value at 0 and the stop value at 10. So if I want to have 11 evenly spaced values in between them, I can do this and I run this. So here are 11 values which starts from 0 and ends at 10, and they are evenly differentiated by 1. So these are evenly spaced out by 1. So I can make it more clearer by using 5 over here. So if I use 5, there's 0, 2.5, 5, 7.5 and 10. 5 values with an even space of 2.5 in between them. So now if you guys actually want to generate random values in the ND array, what you can use is np.random dot, and you can see here that there are a lot of different things that you can call on this. I'll be calling the randint for now. So what it basically takes in is a low value and a high value. What that means is that 0 is the lowest value the random generator will generate, and another thing, here 10 is not actually the highest number that the random generator will generate. Here 9 is the highest number that the generator will generate as in the range function, so keep that in mind. So if I generate from this, there's 7. Now I can also give, let me do this once more. So there's 0 as I was talking about, and let me do this, there's 9. So it goes on like that. I can also give a shape to this, so I can call a tuple of 3 by 3, and here's a 3 by 3 ND array. So that's one way to generate random values, and you can see that every time I generate this, their values keep on changing. So if you want to actually generate the same random values, what you can use is np.random.seed and provide a seed value. Here I'll put in 101, which I normally use. So after doing this, you can see that the random values do not change. So that actually saves the state of the random generator in some sense, or provides a seed to it. So let me show you some other functions you can use. So let me convert this into a 1 comma 10. So what it looks like is like this. So I can call the max function on it to find the max value, which is 9. I can call the min function to find the list, which is 0. I can call the mean function on it to find the mean of the ND array. And if I want to find the position of the max value, I can just call arr.argmax. So that gives me 3, which is 0, 1, 2 and 3, which is position of the max value. So I like to end this crash course with the most important function that I think can be used in an ND array, that is arr.reshape. Reshape basically changes the dimensions of the ND array. For example, we have a 1 comma 10 dimension ND array. Now I can convert this into a 2 comma 5 using reshape. Here you can see there are 2 rows and 5 columns. So yeah, this is a very handy thing that you can use when processing large batches of data. This actually comes into quite some use. So yeah, I hope you guys enjoyed this tutorial, and if you guys have any questions, or if you guys want any other further information about this, make sure to write it down in the comment section. Ta-da!